So.
Okay.
Okay.
All right. Now,
Yeah.
what we'll do our homework, and then I have to go over some exponent rules again, and how you can modify the scientific notation. And we'll look at probabilities. And if we have a chance, we'll look at what we call combinations and permutations. We may not get to that, but if not, we'll get to it on Monday. All right, let's look at the homework. I got homework from Alva, Mercedes, and Maureen. And Alva did really well on her homework. Well, she about 2 or 3 of them I had to do again, and she got them all right. So she only, I think, missed a couple of them. And I think both of you got this one right.
I had that right, but I missed the wrong number.
No, I think you had it right, Maureen. Let me check my book because I recorded what you had. Mercedes, I know you had it right. Okay. No, Maureen, you didn't have that one right. You said
I had it right,
yes.
but I really hit the thing. I put instead of B, I put A. Yeah,
Yes, you put A, and I said I know you know that.
Yeah, so my hand must miss and hit the button. Yeah.
Okay, yes, you did put A, and I said
I'm too good at typing.
well, you know, when you see something like this, you could have said yes or no, you know, because I would check
Okay.
it. All
All
right.
right.
If you see like A and a B, yes or no, true, false, you can say
Okay.
what it is.
Okay.
Because I know I get both answers sometimes. The letter represent the answer and then the answer itself. But either way, you know, I'll check it if it's correct. I'll check it correct. Now, I knew you knew this, Maureen. 34 is not between 1 and 10.
I know.
Right? So for scientific notation, 2 parts. First part, a number between 1 and 10. The second part, 10 raised to a power. So this is not a number in scientific notation. And why is not a number in scientific notation, Mercedes?
Oh, because Miss Barbara is a bit small. Can you blow it up a little bit, please?
Okay. All right, let's make this bigger. Okay, that better?
Yes, thank you.
Okay, now you answered it correctly, and you said no, Mercedes. Why is that expression, that scientific notion, not a number in scientific notation?
Because the right way to answer it is to say put the point between it must be less than 10.
What must be less?
The first 2 digit. The
No,
first digit
the first part
part of
the scientific notation
must be less than 10.
Must be between 1 and 10.
Between 1 and 10.
Yeah. I corrected that. I think I said less than 10 before, but it should be between 1 and 10. All right. Yeah. So that's correct because 34 is greater than 10, right, Maureen?
Yeah.
Okay. Now the second one, let's see. Okay, now let's see. Maureen, you had, both of you had it. Yeah, I'll bring it up and then I'll make it bigger. That was a rewrite. Rewrite the following number in scientific notation. Okay. I think you all had that one right. Okay. And I'll go to the next screen so you can see it. Okay. Now, what is the answer, Maureen?
Yeah.
What is it?
A.
Why is it A?
I count like, okay. I count like, well, I count the, let's call it 1, 2, 3, 4, 5, 6,
The
7.
digits after the decimal point.
Yeah, yeah.
Okay. And you have what? How many? How many digits after the
9.
decimal point? 9, that's right. So the answer is what?
Yeah.
A.
A.
That's it. Okay, because you could just say 3, 6, 9, right? Now you're between
Yeah.
the 5 and the 6, and it's moved to the left, so you know it's a positive, not a negative, right?
Yeah.
Answer A. Let's,
Before you move on, Miss Barbara,
okay.
I'm looking at this number 2, and you have a comma between the 5 and the 6. And one of the question that I answered, I was a bit confused because I see comma and I see the dot. And I was a bit confused what to answer. So
Oh,
maybe
but the comma separates what? What does the comma separate, Maureen?
pretend.
Separate the 8 and the 0.
No,
It's 5.
the commas, how would you say this number in words, Mercedes?
This 5,000,000 678,000 9. Oh, am I calling it right? 900. Did I call it right? No.
No.
Oh boy.
How would
5,
you say this in words?
5,000,000.
Okay, remember place value?
Oh, 10.
This is what?
100.
What is that right
100.
here? That 0 right there is what?
1.
And this one?
10.
Okay.
That is 100.
And this one?
And just
100.
You just said 100 here.
Oh,
Now what is this one?
1,000.
Okay, and this one?
I don't remember.
Maureen, you know what that one is?
10,000.
10,000. What about this one?
It's my mouth. I didn't say it.
What's that one,
100.
Mercedes? The 9.
100,000.
The 8.
Um,
What is the 8? Mercedes?
I don't remember.
Maureen?
100.
What? You said 100,000 for the 9. What is the
Yeah.
8, Maureen?
1 million.
That's million. What about the 7, Maureen?
Million. Trillion.
No.
10 million.
Million, 10 million. What about the 6?
100 million.
100 million. And the 5?
I don't know.
Billion.
Or billion.
And oh,
Mercedes?
oh boy. So it's
You gotta review you. So say it in words, Mercedes. What is that number?
5,678 trillion.
No.
Oh boy.
Thousands.
No.
2009.
5 billion.
Mhm.
678,900,000.
Oh,
That's
Oh,
what you say in words. Go back
uh,
and review your place values. One, tens, hundreds, thousands, 10,000, 100,000s,
so it's 5
million,
billion,
10 million,
billion,
100 million, billion.
hundreds.
All right.
Yes, miss, but that's what I'm talking about is a comma and the dot. When you go to the
No,
backside
the
square.
comma is separating increments of 3.
Oh,
And
yeah,
then,
yeah.
yeah, see, three,
No, the
three,
one between
3.
the
And
5
then,
and the
yeah, that's separating. So that's helps you know that this is billion, right? That's billion. Starting here is million, hundreds of millions, 678 million.
okay.
All right, then 900,000. And then since these are zeros, you say 900,000.
Yeah.
If this was like a 1 where there's 0, then you say 158. If it's 158. Okay.
I think I'm gonna practice that. It is a shame. I didn't know.
Yes, because this is place failure. That's fundamental. We went over that back in the beginning, right?
Yeah, that,
Okay. See, if this is 900, that's 100,000.
yeah.
So after you pass 100,000 going to the left, you are like million, tens. Now notice now, ones, what, tens, hundreds, thousand. See, that's 10,000, right? 100,000, million, there's 10 million.
Okay.
Notice the 10. And if you kept going, it was a bigger number. You could have what? Tens of billion.
Okay.
Okay, you got it?
Yep.
Yeah.
But all you do is just say 3 digits, 3 digits, 3 digits, and puts you right here between the 5 and the 6. So you have 3, 6, 9. So your exponent is 9. Okay. All right, let's go to number 3. And you want to express this 67.9 in scientific notation. All right. Let me put all that on the next line. Let's see, that was number 3. Okay. So, Mercedes, you had it right. So how did you solve this?
Oh, I look at it says how is 67.9 expressed in scientific notation.
Okay.
So I look carefully at how they are set out, and it says, oh, if 67, you cannot say 67.9.
That's right, because that's not between 1 and 10. So
It must be 6.79 times
that's right. 6.79 is between 1 and 10. And you moved it how many places?
one place.
One place to the left. So what's the answer?
D.
D. That's right. Because 6.79 times 10 is 67.9, right?
Yeah.
Because 10 to the 1 is just 10. So you can always check it, right? Because 10 to the 1 is just 10. 6 times 10 is 60. 6.79 times 10 is 67.9. Now, number 4, let's see, Maureen, you didn't get that one right on the first try.
Can you bowl up, please?
Let me,
Miss?
yes.
Yeah. I
Oh,
had
there.
my way on the first one.
You got it right the second time, Maureen. You missed it the
So,
first try.
but no, you missed it. But I used when I said 6 questions to you, you tell me to do back over 1, 5,
Yes.
and 6.
Yeah.
Yeah.
Okay. Number 4. No, I said do 4, 5, and 6. 4, 5, and 6. Now, Maureen, what's the answer for this one?
Yeah.
Let me bring it down here.
You told me number 2, 3, and 4 are correct. And then you tell me to try 1.
Oh, wait,
5,
I'm
6, and
sorry.
7,
I'm
8.
sorry. Yes, I'm looking at
Yeah.
Alva's. Yeah, I said 2, 3, and 4 correct, and I asked you to
Yeah.
try the other ones. Yes, you're right. Absolutely. Okay. Now, Maureen, what's the answer for number 4, and why did you choose it?
Let's see. If I tell you how I choose it, I don't got a clue.
What is the
I
answer?
B.
And why did you choose B?
I choose B because it looked more familiar.
No, the rule. Where do you move your decimal point, Maureen?
I know what this look like one place. It was, let's see.
Your decimal point, you said B, right? It's right here.
Yeah,
So where did you move this decimal point? Because it says, which of the following numbers can be written in scientific notation as 5.7 times 10 to the minus 6?
yeah.
So we know we're moving it to the right. So where did you move your decimal point?
Behind the 5.
Okay, why?
I ain't got a clue why.
What?
To be truthful.
Okay, Mercedes, you want to help her out? Why did she move it where she did?
You mean number B? Because
Yeah.
it's a negative to the left. I'm going to remember the position, the rules.
No, you're moving from this position to
right.
between the 5 and the 7. That's to the right.
Yeah.
Now, how many places did you move it, Mercedes?
I did,
Oh, 6 places.
6 places. That's why you have a negative 6,
oh, yeah.
right?
The negative.
Maureen, you say you don't have a clue why you did it, but you want to be the decimal point between the 5 and the 7. That satisfies the first part of the scientific notation being between the numbers 1 and 10. So how many places you move it? Just count. 1, 2, 3, 4, 5, 6.
Yeah.
Moved it to the right, negative exponent. Maureen, is that clear?
Yeah.
Okay, so I don't want to hear you say I don't have a clue again. Okay, because there's some rules here and we're just following those rules, right?
Yeah.
Okay, Mercedes, you had a question? You had that one correct.
No, I don't think so.
No, you didn't. You had D.
That's right.
Yeah. Did you count?
I was confused with the comma and the dot, and I said, why she have a dot and she have a comma? Is it something different because it's gone that way? But I'm not
The
sure.
comma just separate increments of 3 digits up
But I didn't
until
even
the
realize it.
last 2. Okay,
The negative,
last.
I didn't even realize the negative 6.
Well, the comma really helps you know what the number is. Like if I didn't have the commas here, it wouldn't be as clear that this C is 57 million. So
Okay.
that's moving the decimal point what? To the left. So that would be a positive power. So you know it can't be C. C you can eliminate. A too, because you've got a negative power. So negative power, these numbers won't match A and C, right? Because you move your decimal point to the right. So it has to be between B and D. But you said D, but D is how many places? It's right here, Mercedes. How many places you move it between the 5 and the 7?
That looked like 7.
Right here? It's right here. And
Yeah,
you
yeah.
move it between the
Yeah.
5 and the 7. D as in
Mhm.
dog.
Right.
How many places are you moving the decimal point?
That looked like 5 places.
That's right. But what was this? A minus 6.
Oh, yeah.
Okay. All right. See.
And Miss
Okay.
Miss Barbara,
Yes.
then you send my things by email, right?
Yes.
I can't even get them come up my card. It's better go into it, right? And I press email, it tell me access and share files across device, security, backup your files, claim your free cloud storage, and then tell me sign in to require, sign in or sign up for free. That's all they get, and they have to wait until G come in And then she got to go all back to it to find them not working. Come to how much you get this for work?
You mean the homework? I emailed you your homework. You couldn't find it?
No, it doesn't press it. A lot of things come that tell me with access and share files, the class device, secure backup files, and all these things coming up on it. Am I going to the office and everything? Yeah, none of coming up.
You mean you couldn't access your email?
Uh-uh.
But your email address haven't changed.
I know, but
I send it the same email all the time.
yeah, but if I press Miss Becca send me again it. If I press Sarah send me oh then people again about me won't work at not getting it. It tell me about sign up and do this. I'm going to this office and return it over. I know.
Oh, that's strange.
Yeah.
But did you finally get it?
Yeah, she get for me because I had to give her my she had to backtrack all the email to go into who I got the email, like who name I got and this and that. Yeah.
Yeah. Well, because she could search based on my email address and all the emails I would have sent you if you did delete, they would come up. Okay, let's go to number 5. Oh, Mercedes, number 5. What happened?
Did something. I think let me do it again. One time when I do it
Yeah.
and say the wrong answer.
That was 27.10
Number
13 divided by 3 to the 10 to the 8.
Yeah, Mercedes said, you said D, Mercedes.
because
But if you divide it like that, you get out where you get if you divide 2.7 by 3, you get out 0.9.
yes. And then you subtract.
But if you divide 27 by 3, you get 9.9x to the power 5, 10 to the power 5. I know.
Hold on.
But
power,
Maureen,
I
this has to be a number between 1 and 10. So C and D you can eliminate. Because the first part of your scientific notation, remember the rule, has to be between 1 and 10. 0.9 is less than 1. So you can eliminate C and D, right, Mercedes?
Oh,
Oh,
Lord.
but I do back over my income.
So 0.9, say you said, and I think that's what you said, Mercedes, you said 0.9, but 0.9 times 10 to the 5th translates to what?
Okay, 9 times 10 to the 5th.
No, 0.9. Because that's what you said you got, that's what you got, you said, Maureen, right?
Yeah, but then I do over mine, I get 9x to 10 to the power 5. I know, so
okay. What is 2.7 divided by 3, Maureen?
0.9.
Okay. Times 10 to the what?
The 5th.
Right. But remember, the first part of your scientific notation has to be a number between 1 and 10. So your answer cannot be 0.9 times something.
Miss.
Yes.
I divide
Let me just
0.7 by 3, I get 0.9. That's why I choose that one first. Then I do the exponent. And I got 5. Because I subtract.
But that, remember, we just told you the rule. The first part, okay, let me put what you said you got here. Let me put that here. Okay, that's equal. And you say you got 0.9.
Yeah.
0.9 times 10 to the 13 minus 8 is 5, right?
Yeah.
So let's just put that there. But there's something wrong with that. What's wrong with it?
Oh, it's in the ones, it's supposed to be in tens.
No, the 0.9, the first part of your
That's what I'm
scientific
talking.
notation should be between 1 and 10. This number is less than
That's what
10.
I'm saying. It's less than 10. When I say
Yeah.
that's what I meant. When I say the 0 is of no value, it's less than 10.
The 0.9 is less than 10. All right. So let's just copy that there. Now, we can translate that where the number is not less than 10. We can increase this to 9, but remember when you increase the first part, you decrease the exponent, right?
Mhm.
So what does this become, Maureen? Increase the 0.9 to 9, right?
Mhm.
Times 10. If you increase the first part, you decrease the exponent. So the 10 would be 10 to the what, Maureen?
Fourth.
That's it, to the fourth.
Oh, I see.
What answer is that, Mercedes?
The answer is A.
That's right, A.
Oh.
Calculate show me 0.9, so I just accept it and do the exponent.
Yeah, but it's
Oh,
this
oh,
to check to see if you remember the rules of scientific notation. First part has to be a number between 1 and 10. C and D are both less than 10.
Okay.
You got it?
Yes, ma'am.
So mathematically, you do get 0.9 times 10 to the fifth, but this first part of your scientific notation must be between 1 and 10. So you can eliminate a C, you can eliminate a D, you between A and B. Increase the first part, decrease the exponent. Decrease the first part, increase the exponent.
oh, I see.
You increase or decrease by the number of places you move the decimal point. So you move this one place. So you what? Decrease this by 1. 5 minus 1 is 4. Got
Okay.
it?
Mhm.
Yeah. Thank you.
Any questions, Mercedes, on that one?
No thanks.
Okay. Yeah, we're going to look at some more of those. That's one of the exercises I want to look at you with the scientific notation. Okay. Mercedes, read number 6. Let me just make it bigger for you. Okay, read number 6.
The mass of the sun, the mass of the sun is 1.989 times 10 to the 30th power in kilograms. The mass of the earth is 5.98 times 10 to the 24th power kilograms. How many times bigger is the sun than the earth?
Okay, now, okay, so you got mass of the sun.
Mhm.
Okay, underline that. You got mass of the earth. Now, what operation would you use, Mercedes, to find how much bigger is the sun than the earth? What operation?
I divide
That's right. You divide what?
1.99 by 5.98.
Very good. So you did the right thing. So let's see what went wrong, because you did the right operation, but you got an incorrect answer. So you said you divide. So let's just put that here. Okay. Now, when you divided that, what did you get, Mercedes?
When I did that, I got 0.3326.
Okay, so you got, let me put what you said. You got 0
Point three
0.3326, and that's times 10 to the what?
and that's time 10 to the, what did I do? I subtract
Yes, you subtract the exponent of the denominator from the exponent of the numerator. So that was what?
So I subtract what 24 from 30?
Yes.
6.
Okay. So let's just put that there. That gives you the 6. All right. Okay. Now, do you see that answer?
Yeah.
You do? Is that
No,
one of the choices?
hold on. It doesn't say 0 though.
Do you
I
see a
didn't
0.3326?
point.
No, you get, it's a tree.
I just see 3.
3.326.
I just see 3.326. The 6th power, that's the B.
You see one?
I see 3.3626 times 10.
But 3.326 is not the same as 0.3326. Is it?
No, ma'am.
Yeah, this is
No,
like 3/10. This is 3.310 rounding.
So what the mistake did I made it? Are you saying that I should have just left it?
No, you got to
so
do just what we did over here.
you got to do
If,
something next to that.
what do? If you increase the first part, you decrease the exponent. So
Yeah.
what does this become, Maureen?
It become, the 1 become a 5.
So
The 6
what?
become a 5.
Tell me about the first part.
Uh,
0.3326 becomes what, Maureen?
okay. 3.326 become
0.3326 becomes what?
3.326. Probably
3.3.
3.26.
You increase, so you decrease the
Decrease
power. So this would be times 10 to the what, Maureen?
the 5th power.
5th power. That's right. One, just like the one we just did.
I didn't get a part of it.
Mercedes, you divided it. You got 0.3326. So now you know it's got to be A or B, right? But
Yeah.
this 0.33 is not between 1 and 10. So you increase it, move it one place, come 3.326. And remember, I say you increase the first number, you decrease the power by the same number of places you move the decimal point. Move it one place, decrease 6 to 5, and your answer is what, Mercedes? What's your answer?
3.326 times 10 to the 5th power.
Yeah, what is A, B, C, or D?
A.
A. Got it?
Yes, miss, but I didn't know that part of it to do the increase or decrease. I think
I think we went over it. We're gonna do some
Yeah,
more
we
of
went over
those.
it,
Yeah,
but yeah,
we
yeah.
did it, right? But we'll do some more. I have some more examples to do. All right. So when you get a number and it doesn't satisfy the format of the scientific notation, just remember when you increase the first part, you decrease the power. You decrease the power by the number of places you move the decimal point. So you moved it one place, increase, and you decrease the power by 1.
Excuse me, miss, what was the answer for number 6?
Number 6, that was number 6 was A. Answer A. That's 3.326 times 10 to the 5th, because you increase 0.3326 by moving one place to the right, became 3.326. So your power then goes down by 1 from 6 to 5.
Okay.
Got it?
Okay, miss, I'll try and remember that part of it.
Yeah. We're going to do some examples of those. Now, number 7.
But I am so embarrassed about this simple and radical. I do it with so
Yes, what happened?
Every time I
Number
see it on my
7.
own, thinking about it, I just can't hit on my own. I don't know why. It's the first month for a long time.
Remember now, Mercedes, what did I say about rationalizing the denominator? What did I tell you do?
I can't even remember it. Maybe because I want to sleep too much.
You multiply numerator and denominator by the
numerator.
radical.
Right.
So I look at it and I just guess an answer.
No, you multiply the numerator and the denominator by that radical in the denominator. And that's the square root of 2, right?
So I'm going to say 326.
So what it sound was 3 over. Well, I didn't understand it because you had 2 sevens. You see, you had number 7, and then you had the 7 by rationalize, right? So that's what had me confused. That way, say, but I'm not asking to say that because they couldn't understand it. Because you have 7, simplify, and then they say rationalize, and then you had the 7 and the 3.
No, I say simplifying radicals.
Simplify radical.
Right? Simplifying radicals. That's what rationalize is doing. It's
Yes,
simplifying.
You had 2 sevens, right? You had 7 that by simplify, and then you had 7 by rationalize. So I thought it was 7 over 3. That way, then you.
No, I only have 7 here, Maureen.
Yeah, but in my phone give me 2 numbers, 2 sevens. So that way,
Mercedes, did you have 2 7s?
2 number 7?
Yeah. I don't. Let me look at my copy here. I don't think I had the 1
that way, say, I can ask you if it's 7.
No, I printed it out, Maureen. I have simplifying radicals. Then I have 7, and then rationalize.
Yeah.
So I don't know how you got 2 7s, because I only have 1.
So that way, say, I can ask you if it's 7 over 3.
The one I have.
2 radical 2. That way, ask me. Yeah.
I don't know how you got 2 7s, Maureen, because I'm looking at what I sent you, and it was just 1 7. Okay, it's only 1 7. Well, the rationalize, remember the first thing you do is multiply both numerator and denominator by the radical. So let me just put this on the next screen. Okay, so there's your first step. Multiply numerator and denominator by square root of 2. That's the radical there in the denominator, right? Mercedes, you following? You're on mute.
I'm looking at it to see
Multiply both numerator and denominator by that radical in the denominator. That's square root
so
of 2.
you're saying right there I should set it out like that, radical 2 over radical 2 beside
that's right. You multiply, because that's the first thing you do. Multiply both numerator, that's the top number, and the denominator, the bottom number, by the radical. That's square root of 2. Questions on that first part?
So whenever I see you set it out like that,
yes,
first thing I do, just put the radical 2 on top of radical 2.
That's right. Whatever the radical is, put it on top of the other and multiply. So that's like multiplying by 1, because these are the same, right? Square root of 2 over square root of 2 is 1. Now, 3 times the square root of 2 gives you what, Mercedes?
The 3 times the square root of 1, you say?
No, square root of 2 right here. What is it? When I multiply this, what do I get?
The radicand.
No, I just get 3, the coefficient, and square root of 2, right? This.
I'm trying to remember how you did it.
Okay, so the top just is 3 times the square root of 2. There we go. All right. Now, Square root of 2 times the square root of 2 is what, Maureen?
4.
No.
2.
I just get the radical.
Square root of 2 times square root of 2 is 2.
2.
Remember, I said a radical times itself just gives the radicand. So square root of 2 times square root of 2 just gives you the number under the radical symbol, 2. Square root of 5 times square root of 5 is 5. Square root of 100 times square root of 100 is 100. Because square root is really raising it to the 1/2 power. And what's 1/2 plus 1/2, Mercedes?
1 all.
1 whole. So that's how you get 2, just 2 to the 1.
Okay.
Okay, so what do I have here? Hello, Chastity. So what do I have in the denominator, Mercedes?
You have 3.
Hi, everyone. Hi, Miss Barbara. How are
Hello,
you?
Chastity. We're doing the homework, okay? So we have 2 times square root of 2 times square root of 2. Now we said square root of 2 radical times itself just give you the radicand. Square root of 2 times square root of 2 just gives you 2. But look, I have a 2 right here, right? So let me just put that 2 there. And square root of 2 times square root of 2, we said that was 2, right? What's 2 times 2, Mercedes?
4.
4. So what's the answer?
I see.
3 times square root of 2 over 4. That's right. So let's just put here equal. So 3 times square root of 2, that stays just the way it is in the numerator. And 2 times 2 is 4, right? And we just put 4 here in the denominator. And when we go back in here, we see that's answer C. Questions?
I'm gonna go blank again next time I see another one. Every time I do it well with her, and then when I by myself, I said, "Oh my God, what should I do next?"
Well,
Right
remember,
blank.
we're simplifying. We're actually rationalizing the denominator that has a radical in it. And we say rationalize because we're changing it from a radical to a whole number,
Oh,
right? Okay, any questions on this one before we try another one of these? I want you to do one. Any questions on what we did?
let's try.
There's your first step. Multiply numerator and denominator by the radical that's in the denominator. And then after you do that, then you can see if you need to further simplify it. Okay, let me just take another one for you to do. This is one for you to try. Okay, so this is, let me just copy this. I want you to rationalize. Now, this one may be rationalize and simplify, but okay, let me do this. Okay, the number is, let's make that a 5. Okay, 5, and then the bottom number, I'll make this 7 and make this square root of 3. Okay, I want you to rationalize that. Okay, now this one may require rationalizing and simplifying. You decide. Do your first step. What's your first step, Mercedes?
Boy. You see what I mean? I go blank when I look at it. Do like 5 upon 5, 5 equal, you know, radical 5 on radical 5.
You see a radical 5 here? I don't see a radical 5.
Okay, radical 3 upon radical 3.
Radical 3, right? So that means you do what? What's your first step?
That's the first step. Radical 3 upon radical 3. And then you
What's your first step?
put radical 3 upon radical 3.
I want to hear some math terms, Mercedes.
Oh Lord, what is it again?
I want to hear math terms. What are you doing? Multiplying, dividing, adding, subtracting. What are you doing?
Multiply.
Okay, so you multiplying what? Tell me what you're multiplying.
Radical 3 times 5.
Okay, so let me just put the asterisk for the multiplication. So you multiplying square root of 3. Let's put that times 5. So that's correct. So let's just put that here. Okay. Now, what else are we doing?
We're going to put another radical 3 under. Draw a line and put 3 under. Put another one under there. Radical
What do I put here?
radical 3.
Radical 3. Okay, very good. Now you've got your first step there. Now, what do you get in the numerator when you have a 5 times the square root of 3? What does that give you?
You give me back 3.
Numerator right here.
Yeah.
5 times the square root of 3 is what?
15. I'm sorry.
What did you say, Chastity?
15.
Like what I
No,
said.
you can't multiply a number by a radical. It has to be radical by radical, a number by number. So you really just get what,
Get back
Maureen?
the 3.
9.
That's radical 3.
You just get 5 radical 3.
Radical 3. Yeah.
Oh,
you-
it stays the same.
Yeah, it stays the same because you can't multiply a number by a radical. You can multiply a radical by a radical. You
So
multiply,
you
if this were 3, I would say 5 times 3, but this is not 3. This is radical 3. Got it?
Yeah.
Oh my God.
So that would just be 5 square root of 3. 5 is the coefficient of the square root of 3. Now, Mercedes, what do we get in the denominator?
15.
What?
15.
7 times square root of 3 times square root of 3. Right here. What is that equal to?
7.
It's 7. And what is that 7 multiplied by?
By 3.
By 3. Very good. Square root of 3 times square root of 3 is just 3. All right. All right. So now let's keep going. You still have that 5 square root of 3. Let's put that. I'll just copy that whole thing. And the numerator just stays just the way it is. 5 times square root of 3. What's 7 times 3, Mercedes?
21.
21. That's your answer. It's already simplified. Because 5 can't go into 21, so, right? They're both prime numbers. So that's your answer.
Oh boy.
Mercedes, you got it. You solved it. Question, Mercedes?
No, mister. I'm just looking at it carefully. How you did it.
Okay. You want to try another one? Maureen, you want to do one?
Let's do another one, miss, please.
Okay, let's do another one. See, this one came out already simplified, right? Because the 5 is prime, the 21 is prime. So once you get the prime numbers, you'll simplify. All right, let's try another one. Rationalize. Okay, because the more you practice these, the more comfortable you become doing them, actually. Okay, so we want to rationalize 10. Okay. And I want to make this, let's see, 4 times the square root of 8. Okay, Maureen, I'll put this all on the next screen and you tell me what I do first, Maureen.
Okay, you multiply the 10 by the rational 8.
That's right, very good. So let me put that there, multiply the 10 by the radical 8. Let me just put this, put the asterisk, but no underline. Okay, so you say multiply the 10 by the radical 8. So let's just put that there. Numerator by radical 8. And what's the next thing you do, Maureen?
So at the bottom, then you, okay. On the 4, okay, you put 10 to the other line radical 8.
Okay, you say I multiply the numerator by radical 8. What do I do
Yeah.
with my denominator?
Put it up the rational 1 8 on the other 8.
4 times square root of 8 becomes what, Maureen? Tell me what to write right here.
Square root 8.
You throwing away your 4?
4 square root 8.
And then what do I multiply that by?
By 8.
No. Remember, you multiply numerator and denominator by the same thing. So if you multiply that by square root of 8, you've got to multiply the bottom also by square root of 8, right? So this would be square root of 8. Okay. There we go. So I multiply numerator by square root of 8, denominator by square root of 8. Now, Maureen, what do I get in the numerator? 10 times square root of 8 is what?
10 square root of 8.
That's right. 10 square root of 8. So let's just put that there. And what do I have in the denominator?
4 square root of 8.
No. Square root of 8 times square root of 8 is what?
8.
8. So what do I have in the denominator?
8.
You're throwing away your 4?
4 square root 8.
Square root of 8 times square root of 8 is what, Maureen?
Is 1.
No, square root of 8 times itself gives you the radicand. What is the radicand?
8.
8. Yeah, this would just be 8. Right? So 4 times 8, let's make that bigger.
It's 32.
32. Okay, so let's just see if it's simplified. So you have 10 times square root of 8. So let's put that there.
Mhm.
And over 32. 32. Is that simplified, Maureen?
No,
Okay, so what do we do?
divide
Divide what?
8 by 32.
That's a square root of 8, Maureen. You can't divide 8 by 32.
yes.
That's not 8. That's square root of 8.
No. So you divide square root of 4 and 4 and 8.
No, you said it's not simplified. So what do you do to simplify it?
Divide
Divide by what?
by 8.
By 2, by 4.
No. Remember, this is a radical and these are numbers. What are factors of 10 and 32 that are common to them?
5.
5 doesn't go into 32.
2.
2. Okay, so 2 into 10 is what?
5.
So that becomes 5. And we just repeat our square root of 8. Let's just put that there. And 2 into 32 goes how many times, Maureen?
16.
16. That's your answer.
Oh, I see.
Okay, so because we had to simplify it, right? Because you had two numbers, 10 and 32, both can be divided by 2. So your answer is 5/16 times square root of 8.
Mhm.
So that is 8, what? 2 into 32. Give you 16.
That's right. 2 is a factor of 10 and 32. 2 goes
Oh.
into 10 5 times, 2 into 32 16 times.
Okay.
Got it?
Uh,
Any questions on rationalize it?
no.
I'm trying to get how you get back the 8, the radical 8 upon radical 8, and then move on.
Right here, you really multiplying your
Right.
expression by 1 because square root of 8 over square root of 8 is 1. But when you rationalize the denominator, you always multiply by the radical in the denominator. But you have to do the same thing for the numerator because remember, you don't change the value if you multiply by 1. And the radical over the same radical is just 1. So coefficient times radical, 4 times square root of 8 times square root of 8. Radical times itself, just give radicand. That's why you have the 8. The 4 was part of the original problem. So you multiply the 4 by the 8, the 32. Then you look at the numbers and see if they are simplified. You said, oh no, I can divide 2 into 10 and I can divide 2 into 32. So my answer is 5/16 times square root of 8.
Okay.
Questions? To make it
No.
more sense?
Yes, miss.
Okay. All right. So let's go to, okay, number 8. Let's see. Maureen had that one correct.
Oh no.
And Mercedes had it correct.
I did?
Yes. You want to tell me how you did it? Mercedes, you had that one correct.
Miss,
Excellent. Tell me how you did it.
I think I got it wrong because I sat and I what do you call it now?
You had D, and
Yes.
Maureen also had D. But tell me how you got D.
I sat down and what did you do it again? I start divide by
So
3,
I
miss.
didn't have D, I didn't send it that to you.
What is it, Maureen? You had D.
No, I didn't send that one to you.
Oh, wait, just a minute. No, you didn't. You didn't send me that one. I'm looking at Alva.
After I
Alva
got,
had it, right?
I didn't do that, but then I come
No,
back
you
and do
didn't.
it.
You
Yeah.
did you do it?
Yeah,
So what, Maureen, you did it?
yeah, but just guess it because it was hard to figure out.
Okay, don't worry. Mercedes is gonna help you out.
Oh,
Mercedes,
miss, it's hard to figure out. She's right. But I tried to divide. I divide 243 by 3 and break it down to 8 and break it down to 27, break it into 9. And I said, oh my God, what do I get to do to get 21? I said, you know what? I'm going to choose D because I don't see no other one is the answer.
oh, you didn't break it down?
I try to I break down the 243 as much as I can, and the 7.
Okay, so we've got 7 times square root of 3. Leave that just the way it is because that's a prime number, right? But now let's take this square root of 75, Maureen. What are factors of 75?
5.
5,
5 and what?
and 25.
5 times 25 is not 75.
Oh, 15.
15?
5 is 25, 1 is 5, and 2 is 7.
But neither one of those have a perfect square root.
Oh, yeah.
Give me 2 factors of 75, one with the perfect square root.
5 times 15.
Hmm?
5 times 15, miss?
What?
5 times 15.
Neither one has a perfect square root.
Okay.
2 factors of 75, and one of them has a perfect square root. What would it be? Maureen, you can't think of 2 factors?
3, miss.
3 and what?
25.
3 and 25.
Yeah.
25 has a perfect square root, right? So you break that down into its factors. That would be 25 and times the square root of 3. So let's just put the 3 here. What's the square root of 25, Mercedes?
5.
5. So that would be 5 times the square root of 3. Got it? You already have 7 times square root of 3. Now you took your 75 and you made it square root of 25 times square root of 3. Square root of 25 is one of your perfect squares. That's 5. 5 times 5 is 25.
Mhm.
Now let's go to our 243. All right, Maureen, what are the factors? One with a perfect square root.
I divide 243 by 3,
Okay,
and then 81.
that's right. So this would be 81. Let's put that there. 81. 81 has a perfect square root of what?
9.
9. That's it.
Mhm.
So let's put our 3 there. Square root of 3. We're just doing our factoring. And what is that equal to, Mercedes? The square root of 81?
9.
9. And that would be times square root of 3.
Okay.
Okay, now add those up.
That's the part of
Add the
confusion.
coefficients. So we have 7. So let's just put that there. I'll put it here because you're going to add these up because they have the same coefficient. So that would be 7. Let me bring this to the next 7. Okay. And we have what, 5 plus, that's a 5 times the square root of 3, right? And what was the other one? 9
Yes, miss.
plus 9 times the square root of 3. Now add up the coefficients. What do they add to, Mercedes?
19. Hold on. 7,
7 plus 5 plus 9 equal what?
12. Hold on. I think I missed a number. Sorry. That is 7. What? 7 plus 5
Plus 9.
plus 9. Give me.
21.
Oh, that's. Oh, I said
21
what?
times square root of
I
3.
couldn't remember. I couldn't remember that part of it. I
Yeah,
said no.
it's a coefficient. Remember I say it's just like if you had x, right?
Just
You
couldn't
could,
remember. So it's 21 said, but I'm choosing D because I feel is the answer.
okay. But see,
I should get that right by this time. And I only
definitely,
divided,
yeah, because both the 75 and the 243 translates into radical 3 times another radical. And that
Yeah.
radical is a perfect square root.
yeah, I had my work up to that, but I didn't think about adding the 5 to the 7 or 9 period. So that was just saying it.
No, remember the purpose of getting them where you have this. Remember I say your clue here was just square root of 3, right? The smallest one. So you think of what does square root of 75 break down into? 3 and what else? 243, 3 and what else? 81, 3 and what else? 25. Got it? So we took square root of 75 and we factored that into the 5 times square root of 3. We simplified it. And we took the square root of 243, simplified that to 9 times square root of 3. Now we have coefficients of the same radical. 7, 5, 9. We can add them. Just like if we had variables here. 7x plus 5x plus 9x will be 21x.
And what the reason why I choose the 7 to the D to miss? I said, by the way, 3 into 21 is 7. 3 times 7 is 21. I said, it must be this answer.
Oh, that's why you chose it.
That's one of the reason I chose it too. I use common sense. I said, come on, this must be the answer.
Okay, but there's a method. You see the method, right? Take the ones, the radicals that does not have the square root of 3 and get them with the coefficient of square root of 3. So 3 into 25, 3 into 75, 25 times. 3 into 243, 81 times. 81, perfect square root. 25, perfect square root. So we just took these and translated them into coefficient square root of 3. Coefficient square root of 3. Then you could just add them.
Miss, please put back that part, Miss. The part there.
Right
Yes,
here? Okay.
yeah. I'm just looking at it. I'm just gonna write it off to go over it again so I don't forget
Yeah.
something.
See, 7 times square root of 3 was in the problem, right? So we just said, well, I remember I told you that's your clue right there, that square root of 3. So 3 in this 75, 25 times. 25, perfect square root of 5. 3 in the 243, 81 times. 81, perfect square root of 9. Now it's just adding up the coefficients. 7, 5, 9, 21. And your answer is D. Questions?
No, Miss.
Okay. All right. Now I want to look at, let's see, you do a new share. I want to look at, let's go back to scientific notation. we're going to go back to these, when you have something in a format and you need to change it so you can do calculations, okay? Now, the general format of scientific, you see the relationship between the two parts of scientific notation?
Mhm.
Okay,
Mhm.
so the first part we call A. That's some number, right? But it has to be between 1 and 10. And then we have the second part, 10 to a power. So if you increase the first part, you decrease the power. And how do you decrease it? By the number of places you move your decimal point. If you decrease this first part, you increase the power.
Okay.
Now, I have some examples here. 2.45 times 10 to the fourth. Now, from 2.45 to 0.245. Is that an increase or a decrease, Maureen?
Increase.
2.45 to 0.245?
Decrease
That's a decrease, Maureen, right?
because of 0.
2 is bigger than 0.2, isn't it?
Yeah.
Okay, so that's a decrease. So I moved the decimal point one place to the left. I did a decrease, then I increased the power by 1. So that
Oh,
becomes 10 to the 5th.
yeah.
Got it?
Yeah.
Here's another one. 0.0678 times 10 to the third. I move my decimal point between my 6 and the 7. Is that an increase or decrease, Mercedes?
Increase.
That's an increase, right? How many places did I move my decimal point?
1.
Which one you doing, miss?
Right here, 0.0678.
Right. Okay.
How many
So-
places I moved the decimal point?
You move a decimal point 3 places.
0.06 to between 6 and 7.
Oh, I'm
How
looking
many?
at it wrong. I'm looking at it wrong. My screen is a little small. Hold on. I'm very closer to my eyes. Okay. So,
Decimal
okay.
point here, and I'm moving it between the 6 and the 7. How many places is that?
It's 2 places.
2 places, right? And it's an increase. So 2 places, my power then must be decreased by 2. 3 minus 2 is 1.
1.
Let's say this, you with me?
Yes, yes.
Okay. So 6.78 times 10 to the 1. Now look at this one. 9.356 times 10 to the minus 2 to 93.56. Is that an increase or decrease, Maureen? This one.
Let's see.
9.356 to 93.56. That an increase or decrease?
A decrease.
No, 9. What's bigger, 9 or 90?
9. See.
Which one?
9.
What is bigger, a 9 or a 90?
And 90.
So what is bigger, a 9.3 or a 93?
And 93 is bigger.
Okay, so if I'm going from 9.356 to 93.56, that's an increase.
Increase.
So I have to decrease by the number of places I moved it, right? So if I move 1 place, I decrease this by 1. So this becomes a -3. A -3 is lower than a -2.
Okay.
Remember with your negative numbers, think about your number line. All right. As you're going from right to left, your negative numbers, absolutes get bigger, but the actual number is smaller. Got it?
Yeah.
Yes, sir.
Okay. Now, I want you to try these. 37.25 times 10 to the n. And we're making this 3.725 times 10 to the fourth. What is n? Mercedes.
N is 3.
And this one?
3.
3. Is that okay? So you're doing a
Decrease.
decrease, right?
Yeah. Yes.
So if you're going from 37.25 times 10 to the 3 to the 4th, that's an increase.
Hold on. We're going from 37.25 times, what's the number there? Is it number or in the letter at the 10?
Yeah, the right here,
N.
Yes.
that's an
And-
N.
Okay.
In other words, what is the power here if I'm going from 37.25 to 3.725? That's a decrease, right?
Mhm.
So if that's a decrease, then what must this N be?
Maybe 1. Not quite sure in the letter.
Increase.
It's supposed to be a decrease.
Well,
No, 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 no,
37.25
no. Increase.
37.25 to 3.725 is a decrease,
A decrease.
right? Yes, 3.7 is less than 37. That's
So
a
that
decrease.
Uh-huh.
So if I did a decrease, then what happens with my power?
it's supposed to be less. So N would be 3.
So from 37.25 times 10 to the third,
That is N, I see there.
yeah, that's N.
To the N
So
to the
it-
4th.
No,
10 to 4 is 3.
3.725 is times 10 to the fourth. So what is it?
It's 3.
3. That's right. From 3 to 4, because this is decreasing. So 3 to 4. So N is 3. Decrease the number, increase the power, right? Decrease the number, 37.25 to 3.725. The power then is going to be decrease. 3. I'm sorry, increase. 3 to 4 is an increase. Increase the power, decrease the number. And you could check this out. 10 to the third is 10 times 10 times 10. That's 1,000, right? 37,250 and 3.725 is 3.725 times 10 times 10 is 100 times 10, 1,000, 10,000. What about this one? 108 times 10 to the 5th, 1.08 times 10 to the n. What is n? That's a decrease, right?
A decrease, yeah.
Yes, so it's N is
How many did it decrease by?
1.
How many?
1.
No, 108 to 1.08. My decimal point is here.
Oh,
I
oh,
moved
3.
it 2
3, sorry.
places, right?
2.
So it decreased by 2. So what is the n?
The N now becomes
3.
Decrease, power, then increase.
Oh,
So what would the n be?
2.
No. You went from decimal point here to decimal point here, right? That's 2 places. So that's a decrease. So your power then must increase. So 5 goes to what? What does this n be?
6.
2 places,
7.
7.
oh, so because
Power
you're
goes up, number goes down. 2 places, I moved it. So my number then goes up by 2, 7. Got it?
so
So the
say it again.
other one then,
Well, 108 to 1.08 is
Decrease.
decreased by 2. So
Okay.
power increased by 2. 5 plus 2 is 7.
Okay. So the other one,
What about 0.715 times 10 to the second?
that is
Ah.
decrease,
No, that's an increase.
increase.
715, that went up by 2, right? So if
Yeah.
that increase, what happens to the 2?
It,
Uh,
it decreased.
Decrease. So what is
Good.
N?
one.
No.
It decreased, you said.
Yes.
Decrease, increase, that's
3,
4.
No.
3.
No.
4
No.
is 3. No.
Decrease.
You
What's
say you
2 minus 2?
1, 0.
0.
Uh,
Right?
yeah.
Yes, it went up by 2, 71.715 to 71.5. That's increasing this number by 2. So I have to decrease my power by 2. 2 minus 2 is 0.
Oh, I see.
So this has to be 0. 71.5, and any number to 0, 1, that's 71.5, right? But 0.715 times 100 is 71.5, right?
Okay.
Okay, try this one. 350.2 times 10 to the minus 4. So I'm decreasing the number, increasing the power. So what is the N?
Decrease and increase.
So the answer for the N is 5.
Oh, this is a minus 4, right?
Uh-huh.
Oh Lordy. I didn't see the minus. Fine.
So what would this number be? What would N be?
Negative,
Minus something, I know.
negative 3.
Well, 2 minus 4 and minus a minus 2 is a minus 2,
Uh,
Yes.
right?
uh,
Minus 2.
Yeah,
Place.
because this decrease, this is increasing. A minus 2 is bigger than a minus 4. That shows an increase, right?
I see.
You got it?
Yeah.
Okay, because sometimes you're given a problem and you want to change it so you can do calculations on the problem. Okay. All right, now let's go to, I want to look at, okay, I want to look at some examples of independent and dependent. Oh, I don't know if you can see that. Okay. New share. Can you see examples of dependent and independent events?
My screen is so small. I'm sorry.
Yeah, I'm going to make it bigger. But can you see examples of dependent and independent?
Yeah.
Okay, so let's just make it bigger. I put some examples here for you. Okay, let's just make that bigger. All right. Go down here and make all of these bigger. Okay, let's go back up here. Let's just go through some. Now, for something to be dependent, one event can only occur if another event occurs first. Okay, that makes it dependent. All right, that's not true of an independent event. Now, we're looking here at some dependent events. Getting into a traffic accident is dependent upon driving or riding in a vehicle. Okay, so in order for you to get in a traffic accident, you must be in traffic. So you're either driving or riding in a vehicle. Those are dependent events. You follow?
Mhm.
Okay. Now, what will happen if you park your vehicle illegally?
Get a ticket.
There's a probability you get a parking ticket.
Yeah.
That's dependent. Okay. You buy a lottery ticket, they have a chance of winning. But if you buy more than one ticket, I think we went through this before, you increasing your odds of winning. Now, your going on vacation is dependent upon what? What depends on whether you go on vacation?
Have enough money.
Having enough money, and if you work, being given time from work, right? Now, what happens when you commit a serious crime?
Get put in jail.
That's it. Increase your odds of getting caught and going to jail. What
Yeah.
happens when you don't pay Con Edison?
Turn off your light.
They turn off your power, right? Now, if you go into an event like a movie, whatever, and you're the first person there, don't you have a bigger probability of getting a good seat?
Yes.
That's dependent. Now, if you take marbles out of a jar and you don't replace them, then what happens?
Oh, that is like a independent.
That's dependent because you took marbles out, you didn't replace them, so your total is changing. So your probability is going to change, right? Because the total marbles left is different. The same if you take cards from a deck without replacing them. Okay. Now let's look at independent events. They're not affected by anything that happened previous. Having black hair, working in Buffalo, completely independent, right? Because you work at Buffalo doesn't mean you have to have black hair.
I know.
Completely independent. What about riding the bus and baking cookies? Independent, dependent. What is it?
Independent.
Winning a card game, running out of bread. In other words, one doesn't have to happen before the other, right? Finding $1 on the street and buying a lottery ticket.
Independent.
Independent. Because you found $1 doesn't mean you're going to buy a lottery ticket.
I know.
No, buying a ticket increases your chance of finding $1.
True.
Growing the perfect tomato and owning a cat.
Please repeat it.
Growing the perfect tomato and owning a cat. Independent, right?
Yeah.
Growing your gardening has nothing to do with your owning a cat.
I know.
And if you roll a die more than once, you still have the same chance of getting a 6 or 5 as if you did it one time. Flipping a coin, probability is still 1/2, right? Because a head and a tail. Spinning a spinner, if you have a spinner with say 6 different places you can spin to, because you spin to 5 has nothing to do with whether you spin again and spin to a 6. Okay, so that's why I wanted to go through those with you. And let me see, I had something else I wanted to do. Okay. Now, let's see. It's not coming up. I had some probability things I wanted to do. Let's see if I can. I wanted to continue the probabilities. Let's see, new share. New share. Okay, here we go. Now we were doing probability before, right?
Yes, miss.
Okay, now we're going back to probability. I think I went through this, but I just want to go through it again. Oh, with our tiles, you have 6 red, 4 green, 3 yellow, 2 blue. Total of 15. The probability of getting a yellow tile is the number of reds possible over the total. Possible over total. 3 yellow, 15 total. 4 green, 15 total. 2 blue, 15 total. 6 red, 15 total. So those are your probabilities. Now, those are simple events. But if you're drawing 2 tiles, you have what we call compound events. Now, what happens when you take one out? You don't put it back. What happens to your total?
It decreased.
It decreases, right? So if you had 15, you took one out, how many do you have left?
14.
You have 14, okay? So that's why when you take a red and a green, for the red, 6 over 15, but for the green, now you took out a tile and you have 14 left, 4 over 14. So each time you just decrease by 1, okay? Now, let's look at this spinner. What did I say about mutually exclusive events? What did I say they were?
Mutually increase
When
by
something is mutually exclusive, what does that mean? It can't happen at the same time. No, they can't happen at the same time. In fact, example, like you can't get a head and a tail at the same time, right?
No.
Okay, so those are, so if they can't happen together, they're mutually exclusive. So you can't get a head and a tail. Like here, you can't get an orange and a red. You either get an orange, a red, or a yellow or blue. All right. So there are 10 total outcomes on the spinner.
No.
Now, what's the probability of getting an orange, Mercedes?
what's the probability in orange?
Yeah. Do you see this spin? Well, you know how many. I put the total here. Can you see that?
That would be 1, 2.
Let me just make it a big, okay. Okay. 4 yellow, 3 red, 2 blue, 1 orange. What's the probability of getting an orange?
1, 1 to 1 to 10. Is that
Yes,
10?
1 to 10. That's right. Possible. There's only 1 orange. Total 10.
Yeah.
Maureen, what's the probability of getting a yellow?
1 and 10.
What?
1 up from 10.
How many yellow are there?
4 yellows.
So what's the probability of getting a yellow?
1 out of 10.
How many yellows are there?
4.
So
4
what's
out
the
of 10.
4 over 10, right?
Yeah.
Possible. You have 4 yellows, so that's your possible. 4 over 10. Mercedes, what's the possibility of getting a red?
3 to 10.
3 to 10. All right. So this is 3 to 10. What about a blue, Maureen?
2 out of 10.
2 over 10. Now, let's just simplify these. Sometimes they're not simplified, and your answers may have the simplified version. 4 over 10 simplifies to what, Mercedes?
Say it again, please.
4 over 10 simplifies to what fraction?
4 over 10 simplifies to, that is 2 and 1 upon 10.
No.
Hold on.
What number goes into 4 and goes into 10?
Oh, 2. So 4, you say 4 into 10. That is 2 and 2 upon 10.
No, you know how to reduce a fraction, right?
Okay. That is 2 and 2 upon 5.
That's right. 2 over 5. Okay. Maureen, 2 over 10, simplify.
1/5.
1/5. That's right. So simplified is just reducing what we call, say, reducing to the lowest terms, right?
Yes.
Now, let's look at the same splitter and get the probability of getting a yellow or red or a blue or yellow or red or blue. Now, we use what we call the addition rule. So let's go to the yellow. What's the probability? You first get the probability of the yellow. So let me just say probability of yellow. And this is the addition. So then we add plus probability of red. So what's the probability of the yellow? Mercedes.
The probability of the yellow. I don't clear to understand that part.
How many yellows are there?
Four.
4. And what's the total?
The total amount of places, 10.
10, right? Okay. Now, what about red? How many red are there?
3
3.
to 10.
Right. And when they add together, you get what?
Oh, we get 7 upon 10.
That's it. That's the addition rule.
Okay.
To get one color or the other, you get the simple probability of each event, and then you add them. So yellow is the number of yellow, 4, that's over total, 10. Number of red, 3 over 10, add them together. So the probability of getting a yellow or red is 7 over 10. Now, okay, so now I want you to do the blue or the yellow. Tell me the answer you get.
Should be 6 over 10.
6 over 10, which simplifies to what?
Simplifies to 3 upon 5.
3 over 5. 2 into 6 3 times, 2 into 10, 5. Okay. Okay. Red or blue, Maureen? What's the probability of getting a red or a blue?
5 over 10.
5 over 10. You got 3 into 2. Okay, 5. And that simplifies to what, Maureen?
1/5.
5 over 10?
Or 5 over 10.
Simplifies,
Half.
yeah, 1/2.
1/2.
Half of 5 is, half of 10 is 5. So that simplifies to 1/2. Okay, so that's the addition rule. Okay. Now I have a mutual independent dependent. One or the other addition, both together multiplication. That's the product rule. Okay. So these are your formulas here. You first find the probability of one event and then probability of the other event and then multiply them. That's for the and, but for the or, find the probability of one event, probability of the other event, and then add them. Got it?
Okay. That's what I mean by adding the red and the blue together.
Right.
And
For the
then-
so
then
that
simplify.
that's that when it says one or the other, then you
Yeah.
add, get the probability of one event, say red, and the probability of the other one, which could be yellow, and then add the two. Now I have some events I want you to practice. Okay. Now, Maureen, read example 1. Oh, let me make it bigger. And this is one we're going to use a multiplication rule. Okay. Let's make it bigger. And then you tell me the answer. Okay, read number 1.
You have a cowboy hat, a top hat, and an Indonesian hat. called the song hook. You also have 4 shirts, white, black, green, and pink. If you choose one hat and one shirt at random, what is the probability that you choose a sunset and a black shirt?
Okay. So the two events are independent. Choice of hat has no effect on the choice of shirt. So let me see here. I want you to solve it. The answer. So possible over total. So let's just do, which one you want to do first? You want to do the hats or the shirt?
The hats.
Okay, so let's just say probability of the hat. Because the answer that we asked, what the probability you choose the sangkak and the black shirt. Okay, so the Indonesian hat is called a sangkak. So you have probability. Let's just put this what they ask you, the sangkak hat. The sangkak hat. Okay, Maureen. Possible over total. So what would that be?
Hat over shirt.
No, we're talking hats now.
Uh,
Let's go back up here. How many hats do you have?
2 hats.
You have a cowboy
White
hat,
hat,
a top
top
hat,
hat,
and an
and
Indonesian hat. So how
top
many
hat.
hats is that?
3.
3. So you have 3 hats. Okay. So let's go to our probability. So the probability of getting a sangkak hat, possible over total. So what would that be?
It'd be 3.
What's the possible?
3.
No, there's only one sangkak hat.
1 over 3.
That's it, 1 over 3. Got it? There's only one Indonesian hat. All right. Now let's go to, and we want to get a black shirt. So let's go to probability of a black shirt. Okay. Now, Maureen, how many shirts are there? Let me go back up here so you can see it. How many shirts are there?
Look here. 4 shirts.
4 shirts. There you go. So you have 4 shirts. Right?
Yeah.
White, black, green, and pink. So what's the
Yeah.
possibility? What's the probability of getting a black shirt, Maureen?
1 over 4.
1 over 4. Very good. Okay. So we have, they ask us, what's the probability you choose the sangkak and the black shirt? So you have independent events. We have the independent events, right? So how would we solve that, Maureen? So let's just write this as probability of sangkak hat and black shirt. And this is the multiplication rule. So what would that be, Maureen?
It'd be 1/3.
Okay, so it'll be 1/3.
You said multiplication, right?
Right,
Multiply by 1/4.
that's it. What's that equal to? What is that equal to?
2 12s.
What? Numerators is 1 times 1. Denominators are 4 times 3. So what's the
Yeah,
answer?
112.
112. That's right. So the probability of that Indonesian hat that they call a sangkak hat and the black shirt will be 1/12. Now, Mercedes, what's the probability of a cowboy hat and a white shirt?
A cowboy hat and a white shirt. That's let me see. I didn't see Miss Barbara, I would be very falling asleep. I said the amount of white shirt. I'm sorry.
There's 3 hats and 4 shirts. So I ask you, what's the probability of a cowboy hat? Let me just put this here. So the probability of a cowboy hat, let's make that a cowboy hat.
We have a total of hats, miss.
Cowboy hat and a white shirt. So this is cowboy hat
That is 3 to 4.
and a white shirt. So what's the answer, Mercedes?
You said 3 hats? Are there on 1 white shirt?
What's the probability of getting a cowboy hat and a white shirt?
I just want to see how much.
Okay, here
Yeah.
we go.
So small.
Cowboy
Yeah.
hat, top hat, Indonesian hat. We call a sangkak. 4 shirts, white, black, green, and pink.
4 shirt, white, black, green, and pink.
Mhm.
4 shirts. So 1 is 1 to 4.
What's the probability of and cowboy hat and white shirt? What would this be?
Is that 1 to 4?
What's 1 to 4?
I'm trying to remember which of them is just waking up again. 1 to is it how many shirts again? I beg your pardon, miss. I'm so sorry.
4
How many shirts?
shirts.
4 shirts in all?
4
Okay.
shirts,
Yeah.
3 hats.
And 3 hats. Okay. So you're asking how many, what's the possibility of
What's the probability that you choose the cowboy hat and the white shirt?
4 to 3?
This is an and. Maureen, what's the answer?
4 and 3.
No. Maureen, what is
What
the
is it?
answer? What's the probability of getting a cowboy hat and a white shirt?
2/12.
How are you getting 2/12? Well, it's really the same as the sangkak hat and the black shirt, right?
1/3 and
1 over
1/4.
3 and 1 over 4. It'd still be 1/12.
Uh,
Still a multiplication. The simple probability for the hat is 1 over 3 because there's 3 hats. For the shirt is 1 over 4 because there are 4 shirts. Multiplication gives you 1/12. Got it? Okay, now. Okay, now let me go here. Okay, now we have some cards here. We're going to go to examples 2. Okay, let's see. Let me just make this bigger. And Maureen, I want you to tell me the answer. Okay. Okay, Maureen, read number 2.
Suppose you take out 2 cards from the standard pack of cards, one after another, before replacing the first card. What is the probability that the first card is an ace of spades and the second card is a heart?
So these are dependent events, right?
Uh,
Okay.
But it got me through the news that they find Donald Trump ex-wife died in her apartment.
What?
Donald Trump found, Ivanka Trump found dead in her Upper East Side home, his first wife.
Yes.
Yeah, they said the phone she home dead in the Upper East Side apartment.
They found her dead.
Yeah.
Oh my goodness.
Mhm.
Found who?
Trump first wife.
The mother of those children, the first 4 children, I think.
Oh, Lord.
Oh boy, that's sad. Okay, so probability, and we're saying first card is ace, and second
Hard.
card is a heart. Okay, now, so we want to find the separate probabilities, right? Okay, and then, okay, so probability, let's just take probability of ace. Okay, so if you take a card out of a deck of cards, what's the probability you get an ace, Maureen?
That's 1/52.
That's it, 1/52. That's the probability of any card, right? Because there are 52 cards in the deck.
Yeah.
Okay, now you don't replace it.
So
Right?
you have 51.
That's right. So what's the probability of a heart? The second card is a heart. What would that be?
1/51.
No,
Oh, you have to take out all the armies, then it's before coming out then, miss.
you only took out 1 card. So you're
Then-
left with 51. But how many hearts are there in a deck of cards?
4.
How many hearts?
13.
13.
What, 13 hearts?
Yes, there's 13 hearts, 13 diamonds, 13 spades, 13 clubs. So that's going to be 13/51, right?
Oh, I forgot the numbers of those. Long time
Yeah,
of
what we call them suits, right?
Yeah, long time of card pack. I forgot.
So spades, then a heart. So what you have to do, this is a multiplication. So multiply. The first card is an ace, second card is a heart, be 1/52 times 13/51. So you multiply that out. So let me just take this, copy that, put that on the next page. So this is multiplication. So the probability would be what? We got for the first one is 1/52. So that would be 1. The probabilities we already calculated. 1/52. And we have 13. That's 13/51.
And it's
Multiply that out. That would be the probability of the first card is an ace and the second card is a heart. So you multiply that out. 13
Ones is 13.
and 52 times 51.
52 times 51.
Yep. 2652.
Yeah, 2652.
Yeah, that's the probability. Got it?
I don't
Uh-huh.
get it.
Mercedes, you have a question?
Yeah, I don't get it, miss.
What part you don't get?
Why you get 22652?
By multiplying
The
52 by 51.
denominator is 52 times 51.
Why, miss?
1 over 52 times 13 over 51. Multiplication of fractions, multiply numerators, multiply denominators. 13 times 1 is the numerators, 13. 52 times 51 are the denominators. That's 2652.
Why you have to do it like that? That's what I don't understand. Because
What do
I'm
you-
thinking if it's the probability. Okay.
Yeah, this is probability. The first card is an ace, second card is a heart. So the first card of the ace, that probability is 1 over 52 because the 52 of the deck. But if I don't replace it, I have 51 left. But there's 13 hearts in the deck. That's why I have 13 over 51.
But you're not taking them out. You just have, it's a possibility. 13 over 51. What if you don't put them back?
You're not putting it back. You're taking a card out. That's why you have 51 left in the deck.
Yeah, I understand the 1 over 52. But you're not putting back the 13 either? You take out the all 13?
No. What does it say? What does it say? Suppose you take 2 cards from a standard pack of cards, one after another without replacing the first card. So if you take 1 card out, you got 52. A deck of cards has 4 suits: hearts, diamonds, spades, clubs. There's 13 in each suit. So there's 13 hearts in the deck of cards. That's why 13 is the possible, because there's 13 hearts. But if I took a card out, my total is now 51.
Yes, I got that part of it. But I don't understand the reason why you have to multiply it.
Because that's the rule when you're doing an and.
Okay.
First card is an ace, second card is a heart. Remember, I had some, well, like even when I went through this, the hats and the shirt, the and is using the multiplication rule. All right.
Okay.
Let's see if I had, okay. Okay. Now, if you follow this that I gave you here, do both events have to happen in a given situation? If yes, use the multiplication rule. No, use the addition rule.
Oh,
If you have dependent events, then you're going to have to reduce the total. Independent events, find the probabilities of each event and then multiply. See, I gave you a flow here as to how they go. Addition rule, multiplication rule. Any questions?
okay. I have to read that part over.
Yeah,
I
you
was
got to read that part over because I gave you the flow of how it goes. Let's
I think
see.
this one.
Okay. So now you understand about the cards?
Yes, yes.
Okay. So we're gonna stop here. And I think there's I think I probably give you these as homework. But I just want to look at some real world applications of probability. I think you think this is just all math, but it's used a lot in business. Okay. Okay, so let me just make this bigger so you can see some of the practical applications of probability. Forecasting the weather, sports outcomes, card games, other games of chance, insurance,
Okay.
traffic signals, medical diagnoses that use probabilities, election results. When you hear the election, they said based on 90% reporting, we predict that such and such will win, right?
Yeah.
That's probability.
Oh, yes.
And lottery probability, based on so many millions of people buying tickets, the probability of you winning is like 1 in a zillion or whatever. Okay. Questions?
No.
All right, so we will stop here.
Mhm.
Let's see.
I want to ask a question. You stop recording.
All right. I'm going to stop recording right now.